Let us now talk about the vegetative issues related to the watersheds. Usually many people have certain notions about these vegetative aspects, that they are secondary or not very important, but this is not correct. When we go through the details of what we are going to discuss, it would become evident that the vegetative aspects pertaining to the watershed and the interventions related to that are more important than the engineering interventions that we have talked about so far. In fact, the amount of recharge to water table through these vegetative means is as much, if not more, than all the interventions, all the engineering interventions we have discussed already. This may sound strange, but then when we go deep into this issue, it will become evident that the recharge to groundwater would get significantly increased, even more than what the recharge which we are aiming at by means of the engineering interventions and the works as such. Now let us see what these are. Firstly, we have to mention about the cover crops. Cover crop is nothing but a vegetative growth on the rain-fed land to keep the soil covered. It has two purposes. One is to prevent the soil moisture evaporation that occurs mostly during the dry spells and the summer periods. It will not prevent totally, but then the evaporation gets reduced. Soil moisture evaporation gets reduced. And the second purpose is the green matter or even the dried up matter related to the cover crop would serve as green manure, organic manure to the rain-fed lands. When such green manure or mulch is trampled into the soil structure improves, and this is the other benefit out of the green manure. Now let us see why we need these cover crops at all, and what is the significant role it plays in the total water balance. This word total water balance means that the rainfall occurring in a particular region or a watershed, how it is stored in various domains or how it is made available in various zones. Now let us say if 100 units is the rainfall at a particular place, and for example we take a red soil area in the drought prone regions, then the distribution of that rainfall would approximately be like this. About 10 to 15% of the rainfall would go for recharging water table. About 20 to 25% of the rainfall would go as runoff, surface runoff. And the balance, nearly 60 to 65%, is held in soil moisture zone, in soil, in the weathered zone, which is above the water table. This is held under capillary suspension right up to field capacity and less than the field capacity. That is the capacity up to which it can store water under capillary suspension. So this water which is stored in the soil is used by the crops in the root zone as well as by the trees with its roots spreading right up to water table in some cases. And In addition to this, the soil moisture is getting depleted every summer due to evaporation, soil moisture evaporation. Even though we say about 60% of it is held under capillary suspension in the soil, most of it is lost when the rainy season, when the summer season ends. Now, if we can reduce the soil moisture evaporation to some extent, what does it mean? To that extent, the groundwater recharge would get increased. If supposing the amount of soil moisture evaporation is as much as 60%, of course this evaporation also takes place immediately after the rains, which means again the evaporation from the soil only and the soil top layers. If supposing this evaporation is reduced to say 30%, then when the next rains occur, it can be brought to field capacity with much less percolation, and any further percolation would go for recharging the water table. If supposing there is soil already having some moisture, and when the rains occur, a considerable quantity of infiltrated water would go to recharge the water table. If the soil is bone dry or is at a wilt point, then it has to be brought to the field capacity before it can gravitate down below to recharge the water table. So therefore, any prevention of soil moisture is of great significance in the total water balance. It is of great significance to improve the recharge to the water table. Is it possible? How is it possible to do this? Is it occurring in nature? Let us examine this. In the nature we have a good dense forest, supposing there is a good dense forest, which means there is a good vegetative cover over the land, over the ground, and at times we don't even see the sunlight falling on the ground. Such is the denseness of the forest. And the forest floor will be having a lot of grasses, creepers, small scrub growth and things like that, dead leaves. All these things will constitute the forest floor. In such a situation, when rainfall occurs, most of it would be going to recharge the water table. So therefore, in the forest areas, water table would be at a fairly shallow depth. In spite of the trees taking away so much of water, still there will be a sufficient amount of balance in order to increase the recharge. On account of this favorable groundwater condition in a dense forest, the streams flowing in the forest will have the seepage flow from the groundwater zone. That is also observed during the summer periods. Usually when there is a rain, the runoff occurs, and this runoff would cease after a few days. But in the case of a forest stream, even after the stopping of rains, we find some base flows. We find some spring flows much later than the rains stopping. For example, the rainy season is over by October. We find the base flows or spring flows in the stream coming from very dense forest, occurring even in the month of March or even in the month of April, or also in the month of May in the case of some good streams. So what is this water that flows as spring flow? This is nothing but groundwater. Groundwater appearing as surface water in the valleys. So that is the spring, or that is the base flow. So these base flows are occurring in a well-wooded forest where there is a good growth of trees and where the soil is having some cover which prevents the evaporation of the soil moisture and which also facilitates the direct solar radiation not occurring onto the ground. So when direct solar radiation is not there and when the soil moisture evaporation is reduced, there is scope for getting the spring flows. There is scope for more of recharge to the groundwater. Now, can this be imitated in the rain-fed lands? Can the natural forest be imitated? Those conditions can be imitated as far as soil profile is concerned. Now, let us consider like this. The rainy season ends by, say, middle of October. Then when there is some still moisture in the soil, we dibble certain green manure seeds, mostly the bean variety of seeds, either lab, anumulu or velvet bean or any bean variety. There would be enough moisture in the soil to facilitate germination, and this dibbling of seed could be just after the harvest of the kharif crop or even before the harvest of the kharif crop. When the crop is harvested, there would be already some germinated seed which grows up and it takes the residual moisture in the soil and grows up to February. We don't expect any yields from this green manure crop. We just dibble the seed and don't expect any yield. But then whatever crop that grows during the Rabi period up to end of February has got to be protected. It has got to be prevented from grazing. And if the whole village takes up this activity, then they will prevent the cattle from eating or grazing there. And this will be a cooperative effort, just as what they do in the Kharif period, they have to extend it for the Rabi period. And when that happens, the growth up to February would be there. And later on, the crop starts withering away because the residual moisture may take care of 1 or 1.5 months, and the subsequent winter and dew and things like that can take care of another 1 to 1.5 months. So therefore up to February end it's already green. Many cases it can be green. Then it starts drying up from the month of March onwards or from the end of February. And when it dries up, also it has to be on the ground in a dried shape, a sort of mulch on the ground. And in the month of May, early rains may come up in some areas by middle or end of May or the first week of June. When it rains, then it will be plowed and trampled into the soil and it gets mixed up as green manure into the soil. Such green manure would improve the soil structure, and when this is repeated for 2 or 3 years in the same manner, at the end of every Kharif period we sow a bean variety of seed and it comes up every year like that. The second year growth would be much better than the first year growth. That's because in the first year we already trample some green manure, so there is improvement in the soil structure to hold more moisture. Also there is some additional fertility through organic manuring. So the second year growth will be much better. In the third year growth it will be very good. That means the whole ground will be covered with this cover crop. Now one point arises here. In what way the farmer is interested in this when he doesn't get any yield out of the crop? What he has to do is only dibble the seed and forget about the yields. The yield is in the shape of additional manure for the farmer. For example, if we evaluate the amount of increase in fertility of the soil, it would be about rupees 2,500 per hectare after the third year. Because in the first 2 years it will be less than that. And this is the benefit to the farmer. In addition to this, there is another benefit to the farmer. By virtue of improving the soil structure, it has got more water holding capacity. It can hold more moisture. And during the rainy period or the Kharif season, we usually get drought spells. In some years it could be as small as 15 days, but in some other years it could be 20 days, 25 days or even 30 days drought spell. When such drought spells occur, the additional moisture stored in the root zone would be of great asset. The crops do not wither away even in spite of such long drought spells. That is because the soil structure is improved. The soil structure improvement is caused by the admixture of green manure, and this has got greater moisture holding capacity. So this is another direct benefit to the farmer. And when this benefit is available, the farmer can put more inputs. Now he has a risk factor. If supposing a drought occurs, then whatever input he has already invested or put on the land would have the risk of a failure. So therefore farmers in the rain-fed agricultural concept, they don't like to increase their inputs. They would like to go in for a subsistence type of agriculture because there is a risk of failure. Now when we are ensuring that even a drought spell of 15 days to 30 days, the crop can withstand on account of the increased soil moisture, the farmers can take a risk and increase their inputs and ultimately get a higher yield. Now when the farmer has having the advantage of soil moisture increase, then the risk element comes down and he can increase the inputs. Now let us see the impact of cover crop on the total water balance. As we just now discussed, it prevents the soil moisture evaporation during the dry period because the beating of rain or the radiation, solar radiation is not occurring on the land, on the ground. It is covered with a vegetative cover. So the direct radiation or heating up of the soils is not the same as what it was earlier. So therefore the soil moisture evaporation is reduced. Now what does it mean? It means that the soil is having some moisture when the rains set in next. Because it is having some moisture, most of the infiltrated or percolated water would reach the water table. Earlier it was going for bringing this soil to field capacity or less than field capacity, and the recharge to water table was limited. Now the recharge to water table will get increased for the same amount of rainfall and for the same soil condition because there is already some moisture in the soil. It is found that such cover crop has brought the water table levels significantly to much higher levels, and this is even more than an engineering intervention conducted in a watershed. So therefore this has got ultimately three advantages. One is to increase the recharge to the water table. The second thing is to make NPK fertility values of a much higher order for the rain-fed lands, almost equal to an amount of rupees 2,500 of equivalent chemical fertilizers per hectare, and that is being obtained at no cost to the farmer. If the seeds are supplied free of cost, it amounts to that it's at no cost to the farmer, and it is supplied onto the field where it is available there, and you need not have to convey it also from any distance. So it is made available on the field itself. That is the second advantage. The third one is soil structure is improved, and this improvement will take care of a drought spell during the Kharif period. So the topmost importance in all the watershed interventions will have to be given for the cover crop, because the benefits are very significant, both to the farmer as well as to recharge the water table. The second vegetative item is tree plantations in the watershed. Tree plantations will have to be taken up to obtain a 3-tier canopy. A 3-tier canopy means the first tier would be up to 10 feet height. This includes grasses, scrub growth and creepers, small trees, etc. The second tier is trees of height 20 to 30 feet. The third tier is trees of height 40 feet and above. All these three types of tiers would get intermingled, and it will not be as if one row of first tier, another row of second tier, not like that. They will all be intermingled, and a dense forest will have to develop out of this. The intermingling is to facilitate good cover for the soil of a vegetative type, and when there is grass and dead leaf and other material on the ground, the soil erosion gets reduced or would be almost nil in a well developed tree plantation. This would not only restore the ecological balance which is not there earlier, it would improve the various activities pertaining to fauna, and it increases the groundwater recharge. Now these three tiers have to be developed with a certain amount of programmed activity. That is, usually the trees or saplings are planted during the rainy period. In the first summer, they have to be protected by watering. If it is not protected by watering in the first summer, then the mortality rate will be very high, could be as high as 90 to 95%. If it is protected in the first summer by watering, the mortality rate will be extremely low, would be 5 to 10%. The taproot would get established, and it will take care of the water requirement, moisture requirement of the crop or the tree during the subsequent summers. That is when the taproot gets established. So with the first summer only requiring watering, we have to program for that. An issue may come up. How can we get water in summer? We don't have enough water even for drinking. How to get water for summer? This has to be programmed, whatever may be the requirement or whatever may be the cost of transport of that, this has got to be programmed. Otherwise we have to reconcile with a very high mortality. For namesake we would have planted number of trees, but then the end result and the effect of it would be negligible. So this has got to be taken up as a programmed activity for protecting it during the first summer. Now what are the species of trees that can be grown? So these trees could be anything which comes up locally in that agroclimatic region, which usually comes up in the nearby forest. All those things can be grown, as well as the one which the farmers or the villagers like that most. So this 3-tier canopy, where is it possible and where has it to be grown. All the wastelands, all the banjar lands, all the common lands, wherever there is a common land, this can be taken up as an activity. This is an important activity to improve the microclimate of the area. The third activity on vegetating relates to planting of trees on the boundaries of all rain-fed lands. Now rain-fed lands, rain-fed agriculture lands, they all have boundaries for each field. So in the boundaries, we'll have to plant trees. I will discuss this issue with reference to a diagram. This is the ground level or the level at the top of the field, and this is the boundary of the field, and we have to plant trees in the boundary of the field. Suppose this is the field, this is the boundary, and for this field also this is the boundary. And when the trees come up all along the boundary, then the root spread will be something like this. The crops will be grown on the rain-fed agricultural lands, and usually the impression is when a tree comes up close to the cropped land, then there will be competition of fertility from the trees. That is, the tree roots would take away the fertility given to the crop. Now to avoid that, we have to excavate a small trench on either side of the boundary, which is of width 0.5 meter, half a meter, and depth is half a meter. And this excavated soil can be used for forming the bund, field bund or boundary bund. And a tree can be grown on the bund, and this will have a root structure like this. The roots will not go in the horizontal direction because there is a trench preventing it from spreading in the horizontal direction. So the roots will have to go in an inclined direction like this. And the depth of the trench is half a meter. Usually the root zone of the crop would be less than half a meter, usually about 0.3 meter. So therefore this would prevent the roots of the tree competing with the root zone or with the crops. And these trenches have got twin purposes. What is the other purpose? The other purpose is these branches and leaves will be cut periodically, because this is a green manure type of tree, and when the branches are cut, they will be put into the tree and it will become green manure. So this green manure can be transported to the land and it will add to the fertility status of the soils. So the green manure is prepared then and there in the field itself, and there is no conveyance of it from long distance. This is another advantage. It prevents the roots from spreading in the horizontal direction, and the trench also will facilitate providing green manure. So this type of trees will have to be planted all along the boundary of the field. And what are the varieties of trees that can usually be planted? So supposing we leave it to the farmer, that's the best. We would like to have some green manure trees, from some fuel wood trees, or some which can give him some use of fruit bearing trees and things like that. But the point here is, the entire length of the bund we should have trees. It should be like a barrier. And when this is done for the whole rain-fed lands, and also when the three-tier canopy is developed in the common lands, then the microclimate will get very favorably altered and the environment will get improved and it is good for the crops. The fourth activity is related to vegetative cover within the gullies. Gully slopes require certain treatment and this should be vegetative. For example, agave would be a good medium of vegetative cover for the gully slopes. Similar varieties can be tried on the gully slopes, including creepers, and in addition to this, planting of trees is desirable at the boundaries of the gully. That is, before the rain-fed land starts, there should be a row of trees all along the gully. And if necessary, a trench can be excavated, as discussed just now, to prevent the roots of the tree competing with the crops. So the gully protection has to be both from the vegetative angle as well as from the structural angle. From the vegetative angle, the slopes have to be covered with green matter like agave, and the edges of the gully to be planted with trees, and the bed of the gully to be provided with sunken gully pits.